today. This is the second part of data warehousing and OLAP. Uh, Second part of the first lecture. So the data in the data warehouse goes through the ETL process, which stands for extraction, transformation, and loading. Where data extraction means that we get the data from multiple heterogeneous external sources, and then we get the data cleaned. It means that we detect data quality problems and errors and we rectify them, meaning that we correct them when it's possible. Data transformation, it means that data is converted from its original format into the data warehouse format, from the legacy or host format into the data warehouse format. And then loading, it means that we sort it, we summarize it, we consolidate it, and we create views, we check for data integrity, and we build indices, which is the many indexes meaning, and partitions. So we conduct multiple operations on the data in order to have it in a format that is useful for analytical processes. And then refresh, it means that we will be propagate the updates from the data source to the warehouse. So the refresh means that the data gets into the warehouse. Now, the metadata repository is actually it's an object that stores description about how the data is structured in the data warehouse. Um, Schema, the view of data, what are the dimensions, what are different hierarchies, how data is derived data is defined, also what kind of data marts do we have, their locations and their content. So metadata is actually data about data. Operational metadata, we do have operational metadata, which is data lineage, history of migrated data and transformation path, currency of data, uh, active, archived, or purged, monitoring information, warehouse usage statistics, error reports, and audit trails. So we use operational data in order to um, allow us to um, uh, um, Right. So now we want to discuss how do we move our data from being represented in its original format, for example, in terms of tables and spreadsheets, to become data cubes. Now, a data warehouse is based on a multidimensional model, meaning that it uses or provides data in a form of a data cube. So a data cube, for example, a sales data cube, it allows us to model different dimensions or multiple dimensions about sales. Now, in order to do that, we'll see that in an example. However, in order to do that, in order to model sales is in a form of a data cube, we actually use dimension tables and we use fact tables, which contains some measures. Dimension tables include some information about sales. For example, items, item name, brand, type, or, for example, another dimension, which is time, day, week, month, quarter, year. Okay, so these are dimensions about sales. So sales have the item dimension, which means that information about the items that are sold, and time, which is the time dimension of when the sale took place. A fact table contains two types of data. It contains keys, and you can think of it just as a primary keys, or sorry, foreign keys of dimension tables. And we'll see that in examples, okay? And also it contains some measures. And a measure is actually a number that we calculate based on um, 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 an aggregation of, for example, the sum of sales or the average of sales or the number of items or the, things like that. So these are called measures. Now, in data warehousing, we called an ND base cube is called base cuboid, okay, where the topmost cuboid is 0D, so it's ND. So the 0D, which is the topmost cuboid, and which will hold the highest level of summarization, okay, and it's called the apex cuboid. And the cuboids below that, they called only, or they form data cubes. Now, this is a two-dimensional view of sales of data from an all-electronics store, okay? And in this view, we are seeing two dimensions. We're seeing the location dimension. Oh, sorry, the location is the same. We have the location, it's Vancouver, the item, which is the type, and then based on that, we have time, what types of items are sold. So here we have two dimensions. We have the time and we have the item, and it's fixed within Vancouver. So this is the sales are from branches located in the city of Vancouver. And we have some measures displayed, which is dollars sold, which means that these numbers here represent the dollars sold. How many home entertainment solutions were sold in Q1, which is quarter, which is a time dimension. How many computer items were sold in Q1, and so forth. This is a 3D view of sales data, and it's also showing a measure of dollars sold. So these numbers represent dollars sold. And here it's a 3D because the location here is showing multiple locations. So we have for Chicago, for New York, for Toronto, and for Vancouver. And for each one of them, we're showing based on items and based on time dimension. So we have three dimensions here: location, item, and time, and the intersection is the dollars sold. This is the view. It's a 3D data cube representation of the data in the table, which is the 3D, the last table, okay, showing the time, item, and location dimensions, and the measure displayed is dollars sold. So this is time. This is Q1, Q2, Q3, Q4, okay, and here we have cities: Chicago, New York, Toronto, and Vancouver. The numbers here are missing, and here we have location. So this is location, this is item, and this is time, and this is item. So this is item, time, and location. Now, this is the lattice of qubits. We said that this is the apex cuboids. Sorry, cuboids. This is the topmost one, which combines or shows the all of the dimensions. So we have here time dimension, item dimension, location, supplier. These are dimensions. This is the 1D cuboid. And then when we move to 2B cuboids, we will have combinations of showing supplier and location, supplier and item, supplier and time, and then location and item, location and time, and then item and time. And now we move to 3D cuboids representing supplier, location, and item, supplier, location, and time, location and item and time. So this will only be the 3Ds, and the 4D, which is the base cuboid, will contain all of them. Now, when we want to model data warehousing, we have multiple types of models, but we're going to study three types. We're going to talk about the star schema, the snowflake schema, the fact consultation. Now, the star schema is actually displaying, it's all of them, when we're talking about these conceptual models, all of them are actually about how to display dimensions and facts, dimension tables and fact table. How do we represent them? How do they show? Now, star schema represents or shows a fact table in the middle, and all the dimensions are connected to this fact table. The snowflake schema will have some sort of normalization. If you remember data normalization, when we apply data normalization on databases, which means that we have some hierarchy. That's why it looks like a snowflake. It doesn't look like a star. The fact consultation, in fact, consultation means مجموعة stars. Okay, so if you remember, this is star. Fact consultation means that it shows collection of star schema, and it shows multiple fact tables. They share dimensions of tables, and it's in some cases it's called galaxy schema. Is the star schema. So this is the sales fact table. And if you remember, I said that here we have some sort of a foreign key. So time key, and we have here item key, branch key, and location key. These are the keys pointing to dimensions. So these are how the fact table is linked to dimensions. So these, we have 4 dimensions, then we have 4 keys here. Okay, each dimension will have more information about the dimensions. So item, we have item key, item name, brand type, supplier type, time, time key, day, day of the week, month, quarter, year, branch, branch key, name, branch type, and we have also location, location key, street, city, state or province, and country. These are the measures, as I said. So the fact table will contain keys to dimension tables and some measures. Here, here some of the selected measures based on the problem here. They need the number of units sold, dollars sold, average sales. So these are numbers calculations. Is the snowflake schema. This is the same fact table with keys and measures, and these are the dimension tables, the ones that we explained in the star schema. But if you notice here that the supplier, instead of having it as a supplier name or all the supplier info in one attribute, we actually have a supplier dimension. So we have a sub dimension here. This is what normalization is. So the city will have a city key, and then it points to a city dimension. Now, this is an example of a fact consultation, or as we said, it's a galaxy. So we have actually 2 fact tables. Here we have sales fact table, and here we have shipping fact table, and they contain also keys, and here they contain keys, and here we have items, and we have items. Okay, and they are pointing to the 4 known dimensions, or even more. We have even more here. We have shipper dimension. So it is a bit more complicated, but how do we know a consultation a schema? By seeing that we have more than one fact table. Now, we explained concept hierarchy, if you remember, how we can divide a concept hierarchy in terms of the location dimension. So this is all Europe, North America. Europe will be Germany, Spain. Germany will be Frankfurt, so this is city-based. And here North America, Canada, Mexico, Vancouver, Toronto. And these are the offices. So we'll have a uh, uh, a hierarchy of concepts. Now, if I want to, to look at what types of measures can we apply on a data cube, we can have 3 types or 3 categories of measures. We can have distributive measures, algebraic measures, and holistic measures. Distributed measures, just like count, sum, minimum, maximum. Algebraic measures that are measures that we can compute based on a function that we pass an argument to. For instance, the average, calculating the average, the standard deviation, minimum of a number of a sub part of data, so not the whole minimum set. Um, or we also have or can compute holistic, such as median, mode, and rank. How do we represent multidimensional data? So sales volume as a function of product, month, and region. So if we want to calculate sales, it's actually a function that combines or calculate the sales, let's say in terms of dollars, based on product, based on month, and also based on region. So other dimensions, just like the ones we mentioned, we have the product, location, and time. Okay, and showing, for instance, a region consisting of countries, cities, or offices, a year consisting of quarter, month, day, or it could be divided into weeks. Industry, it can be based on general category or specific products. So this is why the concept hierarchy idea is important, because it allows us to specify what values to have here. The sample data cube showing here, these are the products. Here we have that time, and here we have the country. Okay. Now, this is the first quarter, second quarter, third quarter, fourth quarter, and we have here the products: TV, PC, VCR. The countries we have here: US, Canada, Mexico. And notice that we also have some. Okay, so we have some. Now, this here represents the total annual sales of TV, okay, in the US. Why we say it's annual? Because it summarizes or aggregates the sales of the four quarters. So this is the summary of the annual sales of TVs in the US. Here it will be the sum of the annual sales of TV in Canada. Here it will be the annual sales of TV in Mexico. If we move here, it will be the annual sales of PCs in Canada. Here are the sums. Okay, now when we look at the sum here, we are actually summing the sums. So it will be the annual sales of TV, okay, in all of the countries. So it will be here. The annual sales of the PC in all of the countries, and the annual sale of the VCR in all of the countries. Here we have another sum. So here it will be the sum of all the sales that took place in all products in the first quarter of the year. Okay. Here it will be the sale of the second quarter. Okay. Here it will be the sale of the third quarter of all products for quarter. Now, here it will be the summary of US. So we will actually have all the products that were sold in the US annually. So will represent this sum. This will summarize all of these here. So it should be the same actually. The sum of all the products sold in the US, or the sum of all the quarters sold in the US. So this should be the same number. Here will actually be the sum of all sums. So it will represent the sum of sales in all three countries, looking at all products and looking at all quarters. So this is cuboids corresponding to the cube that we just discussed. So this is the apex cuboid. So we have product, date, and country, and then we look into date and country, product and country, product and date. This will be first D, this will be second D, and here the base cuboid combining all of them. Now, this is it for the second part of data warehousing of the first week of data warehousing. I will stop here, and inshallah next week, the week right after Eid, inshallah, we will be finishing another the rest of this slides. Thank you very much. Assalamu alaikum.